Hi guys, we're continuing to work through the Unit 3 test review. This is our Systems of Linear Equations test review. And we're going to throw it back to some stuff that we learned in Unit 2. Because these are some areas that we saw some difficulty in Unit 2. And it's important to still be able to solve for a single variable. So, for number 8, it says solve for the given variables. A says 2x minus 4y plus 2z is equal to 8. And it's asked us to solve for the variable z. So the only term with the variable z is the third term on the left. So our first order of business is to isolate that z term. In order to do so, I'm going to start off by subtracting a 2x on each side of the equal sign. That's going to leave me with a negative 4y plus 2z is equal to negative 2x plus 8. And guys, I always put the variable term before the constant term just because that is their order of degree. A variable term is always going to hold a higher order of degree than a constant term. Now, I still do not have that variable z isolated, so I'm going to add a 4y to both sides. And my brain thinks alphabetically, so I'm going to rewrite this as 2z is equal to negative 2x plus 4y plus 8. And my last order of business is to isolate z, and I can do so by dividing each term by 2. So therefore z is equal to negative x plus 2y plus 4. Problem B is a little bit shorter, so I'm going to solve for my variable y. First order of business is to isolate the term that has the y in it. That means I'm going to subtract a 6x from both sides. That gives me 3y is equal to negative 6x plus 18. And the last thing I need to do is divide each term by 3. So y is equal to negative 2x plus 6. For C, I need to isolate my r term. So I've got 3r plus 6d is equal to negative 24p. These are all variable terms, but they're different variables. So I can't combine any of them together. So on my left-hand side, I'm going to subtract a 6d to isolate that 3r term, which means I'm also going to subtract a 6d on the right-hand side. That's going to leave me with 3r is equal to negative 6d minus 24p. And my last order of business is to divide each term by 3. So r is equal to negative 2d. And then negative 24p divided by 3 is going to give me negative 8p. For problem D, I've got 2k minus 4y is equal to 6. And it's asking me to solve for the variable k. My first step is to isolate my k term. So I'm going to add a 4y to each side. That's just doing that opposite operation from what's on the left-hand side. So that gives me that 2k is equal to 4y plus 6. And then I need to isolate k, and in order to do so, I need to divide each term by 2. So k is equal to 2y plus 3. For E, it says to solve for x. Now, guys, there's a couple of different ways we could go about solving for E. We could use the distributive property first. We could add 6 to each side first. It's really up to you and what your comfort level is. Because we've kind of showed you how to start with multiplication, let's go ahead on this example and start by distributing the 2. So that's going to give me that 4x minus 8 minus 6 is equal to 14. And now I need to combine like terms. That says that 4x minus 14 is equal to 14. I can add 14 to both sides. So 4x is equal to 28. Last order of business is to divide by 4 on both sides. So x is equal to 7. So for problem F, I got 4 times x minus 3 plus 7 is equal to 23. I've only been given one variable, so I need to go ahead and solve for that variable x. I'm going to do it a little bit differently than how we did e, just so you guys can see both ways. So I'm going to start by subtracting a 7 on each side. And 23 minus 7 is equal to 16. So that gives me 4 times x minus 3 is equal to 16. That 4 is multiplied by every term on the left-hand side. Opposite of multiplication is division. So I'm going to divide both sides by 4. That gives me that x minus 3 is equal to 4. And so my last step is just to add 3 on both sides. So x equals 7. Guys, do you have to solve it that way? Absolutely not. I could have started with distributing the 4, then combining like terms, and then dividing by 4. It doesn't matter which order that you do the steps in, as long as you're consistent about whatever you do to one side, you've got to do to the other side. So you've got to use that property of equality.